multiplication tables are very much boring. So multiplication tables, actually they are just, mugged up. But is there some kind of interest, we can create in multiplication tables so that, the boredom, children's boredom is not there. Or they get interested in some kind of locating some kind of patterns in the multiplication tables. So with this in mind, I have designed, this particular toy. This toy can be opened like this. It contains the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is no 10 here. It is only from 0 to 9. And here we are having in a particular multiplication tables. This is the 2 table. Just like that, there are others. 3 table. Everything is here up to 10. And here what we have is only a thread. So let us see. This is the multiplication table of 2. So let us see what pattern we get when we follow this particular table. So I will start from 2. This is the multiplication table for 2. So I will start, this thread from 2. This is 2. This is 4. This is 6. Next 8. Next 10. So I will put only this is 0. So then 12, 14, 16, etc. So it is a pentagon here. This pattern for the table of 2 is the pentagon which attracts the students. Let us see what kind of a pattern we get for other multiplication tables. So I will remove this thread. I will put 3 table here. So this is the wonderful pattern you get for multiplication for 3. So let us repeat the process. Let us see what happens for 4. This is the table for 4. So this particular pattern, this kind of a star, pentagonal star, is the pattern we get for the table of 4. Let us take 6. What happens for 6? So again a pentagonal star. So let us see for 7. This is the table for 7. So this is the pattern for 7. So is this not interesting? Pi is the universal constant the students are introduced to when they are exposed to this circle. The chapter in circle, it deals with various aspects of circle: the diameter, the radius, the circumference, and the circumference, and also diameter and its ratio. Usually that is called as pi. So pi is always confusing. Even though we use that value for pi as 22/7, it is not accurate. But this 22/7, this value is sufficient up to MSc level for our students. But the question remains, why it is 22/7? Though there are very many experiments that can be conducted in a classroom situation, to get this particular ratio of 22/7 is difficult. So my thinking was that why not we design a toy for that. So this is that kind of a toy. So here you see a boy is turning the circle. So while he turns the circle like this, he has to cover some kind of a distance if it were to travel like this. So let us see how I make a toy to conclude that circumference divided by diameter is 22/7. So this is a toy where the boy is moving this circle. So you can just go on playing it, and also you can measure the circumference like this. Put this arrow at this point A, and then let the boy move the circle. So straight away he comes over here. He comes over here. Then when the arrow mark comes here, it is that point B. So from A to B, this circle makes one turn. That means to say from A to B, this is the circumference of this circle. So now let us measure this A to B with the same diameters of the circle. Look, this is one circle, this is the second circle, this is the third circle, plus this is the point B. This is not a full circle, but only a portion of it. So this is another diameter. So now we have 1 diameter, 2 diameter, 3 diameter, plus only this portion of this diameter. So there is a theorem how to measure this from this point to this point in terms of this diameter. When you measure it by putting a slant line like this, dividing this exactly into 7 equal parts, you will, and also drawing the parallels like this, you will see this parallel exactly coinciding with point B. That means to say the circumference here is 1 diameter, 2 diameter, 3 diameter, and 1/7 of this diameter. That is, the circumference is equal to 3/1/7 of this diameter, which exactly is equal to 22/7. This is a rainmaker toy. When you go on making ulta like this, there is a sound here. So this is sold in the market as a rainmaker toy because the sound resembles the rain falling on some kind of a table. So this is the sound of the falling rain. But it also contains certain windows. When you see closely these windows, there is 1/4, there is 1/4, this is half, 3/4, 1, 1/4, etc., etc. What are these things? These are exactly the kind of tables what I have here. You must have heard about 1 table, 2 table, 3 table, 4 table. But have you ever heard that there are also tables for 1/4, half, as well as 3/4? This is exactly, it is that. 1/4 is 1/4, 2/4 is half, 3/4 is 3/4, 4/4 is 1, 5/4 is 1. So nowadays this is not popular, but this is a must that the students should learn to deal easily with fractions. This toy is about that. For example, in the window here, that 1/4 table is there. When you turn it and also make another turn, here that half table you can see. When you turn it again and turn this way, you can see 3/4 table. Like this toy gives you such a fraction multiplication tables.